Okay, let's begin with just question A form. Okay, solve the simultaneous equations. Okay, simultaneous equations that we have here. So the first pair is talking about 8 times 4 to the power of y equals to 2x minus 1. And, so comma, 3 to the power of y. Then this is square root. They put 3 to the power of x equals to 81. Okay, just are the two equations we're talking about simultaneously to solve. So what is the idea? There's an underlying idea that can solve almost any type of such equations in the general context, which is when you see numbers like 842 on the left hand side, numbers like 3 and 81, just looking at the base numbers, you must understand the secret is always primes. Secret that always solves all of this, the brute force secret, is prime exponents. That means you must write prime to the power of something. So prime and then exponents. Sorry. The prime exponent, the English can also mean something else. Okay, let me just write the secret is primes. Okay, I get confused by the English. I just realized I mean that something else. Okay, here, which is, I mean, the exponent stuff is a prime. That's not what I mean. So 2 to the power of 3 times here, the 4, we write it as 2 squares. So 2 to the power of 2y equals to 2 to the power of 2x minus 1. And then we can use, did you notice at this step, when you use the secret, that means make it the base or a prime of same, then automatically you can see that the bases are same. Earlier it was not. That's why we cannot perform the index law on the earlier step, because there was an 8, 4, and 2. So it only, that means the law only works when the base is the same. Okay, let's perform the index law on it. So this becomes 3 plus 2y. So I'm just going to put it in different color so that it's a bit easier to see the exponent part separated from the base itself. So let's do that. So 2x minus 1. So in this step, the green one, equating the index. Equating the index, or sometimes the index is also called the power. So equating the index of power, what happens? So the 3 plus 2y in green equals to the 2x minus 1. So this is how we slowly forge or form the equation. Let's bring the minus 3 there. So 2x minus 3 minus 1 minus 3. I know I'm breaking out something like this. If you have to write it down, 2x minus 4, then dividing throughout by 2, we get a nice equation, linear equation there, which is nice for substitution. The second part, simultaneous equation. We can suspect it's going to be a simultaneous equation by the very fact or nature that there are two unknowns, two equations. So y is x minus 2. Okay, so on this side, we're going to do the same now. Please take note, I cannot use the index law just yet because the right-hand side and left-hand side are not in the same base. So I just modify first this part, this 3 to the power of x over 2. Square root means x over 2. And this 81 is 3 to the power of 4. Then you realize that at this step, the bases are same. So when the bases are same, we can apply the index law, let's say to the left-hand side. Just write it as an addition, changing the power just like before. So this is y plus x over 2. And then on this side, it equals to 3 to the power of 4. And then we can equate the index of power. What happens? Okay, when you equate the index of power, the pink color one, so y plus x over 2 equals to 4. Oh, when the base is same, we can do that. So the law becomes a bit more clear now. Okay, at this juncture, I just want to substitute it out and solve. So solving part is, idea is just substitute, solve by substituting. I see equation 1 and 2. Okay, that means in the place of y, we use the other letter. Oh, sorry, where is it? Okay, click accidentally. Whole thing vanished. That's a good one. Okay, so that means the green y replaces that y there. If I were to write in a little bit detail, just to help some of you. So y plus x over 2 equals to 4, like this, right? So what substitution does is, it goes to this equation 1, picks up and replaces the y with the letter x. Why does it do that? Because we want to get one variable in one letter that links to the lower level. I mean, you can think of it like the linear equation is the lower level, from which we have complete knowledge of solving. So one variable, one unknown, one equation. and solve for the value of x. So I don't like to deal with fractions. So you can either write like this first, x over 2 is 4 plus 2 is 6. Then multiply throughout by 2, to remove the denominator. So 2x, so become x, this one times 2 is 12. Each term separated by a plus minus on the other side of the equation. So this is 3x is 12. But finally, we can easily see that the value of x is 4. Okay. And divide 12 with 3. So x equals to 4. And then this one we put back. Okay, we put back in which equation? Choose the easy one. Let's say 1. Equation 1 looks pretty easy to put back in. So that means the value of y will be something minus 2, x minus 2. The something or the x is 4. So 4 minus 2, and therefore the value of y is 2. Okay. So if you want to conclude, you can conclude it nicely down like that. You just write in the duplet. Okay, yeah, it's a pair formula for duplet. xy is 4, 2. Answer. Done. Thank you.